So now let's kind of try to calculate what is the distance, physical distance of a degree. So I was just asking what is the, I mean the entire distance if I walk along the equator along the earth, or I sail with a ship, what will be the total distance here covered from this point all around the globe till I'm coming back to the same point. I think if I remember correctly that was 40,000 kilometers. Divided by how many degrees do we have around the globe? 360. So this is an approximation because the earth is a little bit of a potato, it's not like an exact sphere. So this will be 111 kilometers. Yeah, so, and if I convert this now to miles, right? Because I want to come to something more clear for you. What is 1 land mile? That's a sea mile. 1.852 is a land mile. So let me divide, Peter, not multiply. 1,609 meters is a sea mile. So if I divide this by 1.852 meters land mile, trust me, you will get miles. Yeah, I mean, indeed, just simplify a little. So we get 21,000 miles along the equator divided by 360 degrees. Boom! You see something, 60 almost, right? So how many minutes is a degree? So every of these single degrees here along these latitudes and longitudes will be cut into 60 minutes. So that means 1 minute actually corresponds to 1 mile. That's how they derived the mile unit. Okay, so so that means if I divide 1 degree by 60, I get roughly 1 mile corresponds to, I think you're correct, 1,852 is a sea mile, right? Sorry, it's nautical mile. 1,609 meter is the one, but it seems they use sea miles anyway to calculate this stuff. So, and this again, 1 minute will again be divided by 60 seconds. So how much is a second? A second is 0.01666 mile. So let's go back to meters, because we are all in the meter, the empiric thing. So 1852. 1 meter will roughly be, 1 second latitude or 1 second longitude will correspond to 0.03 kilometer, which is 30 meters. So let me zoom in a little bit more here. Look, now I've actually zoomed in very closely onto Nagalapuram. So now you can see this peak here is in this grid. So which means it's somewhere, let's look, see, I've become very detailed now. So now the lines are very much finer. It's not just degrees, it's degrees, minutes and seconds. So if you look at let us first identify the distance of each cell, right? Horizontally and vertically. So I want to see east here. Let's take this line. I mean, this number corresponds to this center line, and this number corresponds to this center line. So what is the distance between these two? We have 47 minutes, 12 seconds, 12.48 seconds, and here we have 47 minutes, 38.4 seconds. So roughly you can say 38 seconds minus 12 seconds. So the distance, 34 seconds. Is it? 38 minus 12 is 26. Madhu? Yeah. So 20 seconds for 2 cells. So 1 cell corresponds to 13 seconds. 1 second is roughly 30, I think it's actually 33 meters to be precise. So 1 cell here corresponds to 420 meters roughly. And probably fairly similar. I mean, the longitude is not kind of the same scale, but fairly similar. 47 seconds minus 21 seconds is 26 again. Yeah, so this again like similar distance. So, and if we verify this, indeed this line here is 2 kilometers. So half of the line is 1 kilometer. A quarter of the line is again like 1 cell is roughly little less than 500 meters. So this seems to be correct. Right, so with this kind of, I would print off this map, if my GPS would give me my location, I would be able to identify exactly in which cell this is. I'm currently located, which would be good, right? Because within 400 meters exactly, I would know where I am on this map. So I would know I am so many meters, actually 200 meters to the right of that blue mainstream, or I'm 500 meters southeast of this peak or something. So having this grid, latitude and longitude grid on your maps is a useful thing, basically, if you have a paper map. If you put this map in your GPS, obviously, then you don't need it, because the GPS exactly know where is the map. It will put your position on the map. Only problem is, of course, that many of the GPSs don't work with these bitmaps, so you cannot simply paste the map, copy the maps in the GPS. Nor many of these maps, again, these Google Maps here, are not geo-referenced. So even though you have the map, you don't know exactly where it is. So I will teach you a little bit later how you can geo-reference without getting in all these mathematics, pure in a visual way, how you can geo-reference the terrain and these Google Maps. Is this clear so far? Latitude, longitude, right? And then obviously the third coordinate will be like the altitude. So the altitude again doesn't really matter to know my position, because there is only one altitude at my position, which will be the surface on which I'm standing. So the altitude, is automatically more or less. Is anyone timing the 10 minutes? Make it a little bit less than 9 minutes, 30 minutes. Okay, so now we know, right? Let's do a test. Can somebody tell me this peak? What is roughly the coordinates of this peak? Degrees, minutes, and seconds. We know every cell is 13 seconds, remember? So what is this line? Always check a nearby line. This will be 30 seconds less than this. So this will actually be 47 minutes and 0 seconds roughly, right? So this is 13 seconds, so this could be 3 seconds. So this will be 46 minutes and 57 seconds, right? 3 seconds below 0, right? 0 actually means 60 seconds. So this is 47 minutes and 0 seconds, or 46 minutes and 60 seconds. So minus 3 is 56 seconds. And then what is my latitude, my vertical position? Yeah. So this will be 28 minutes, and then 29 seconds plus 13 by 2 is 7, so 36 seconds basically. Yeah. So see, even with a grid of 13 by 13, within plus minus 2-3 seconds you can really identify your position. Plus minus 2 seconds means that plus minus 60 meters you know your location, just by visual inspection with the eye, which is pretty good, right? So even carrying a paper map with some like an approximate grid allows you to kind of identify your position easily within 50 to 100 meters without much of a problem. If you have a latitude and longitude grid put on top of your paper map or your bitmap, basically. Having the same in a GPS, of course, will give your position more accurate, up till 3 meters actually maximum, but 3 meters of 30 meters, it doesn't matter that much. Okay, so now let's talk a little about GPS. We'll go through some of the main features. Yeah, let's close session number 10, and let's open session 11.